So, conservation of momentum. I want you to look at the screen, and on the screen we've got two vehicles. One of them is an enormous great lorry, and the other one is a rather smaller car, or we could say less massive car. It's got much smaller mass. For each of those objects, I've calculated their momentum. So we've got the lorry weighing 15,000 kilograms and travelling at 20 metres per second. So to calculate the momentum, we multiply the mass by the velocity, and that comes out at 30,000 kilogram metres per second. Now we've got the car. The car is only 2,000 kilograms, and it's travelling at only 10 metres per second. So it is less massive, and it is going more slowly. And again, I've multiplied the mass by the velocity to give us a momentum of 20,000 kilogram metres per second. So far, just like previous lesson. But there's a problem. The lorry is behind the car on the road, and it is going twice as fast. It's going 20 metres per second compared to the car's 10 metres per second, so it is catching it up, and it is about to collide with the car. It's going to go smashing into it because it is going faster. Now, there is a law called the law of the conservation of momentum, and it tells us that before or after a collision or an explosion, the total momentum of the system is the same. What that means is, at the moment, if we add the momentum of the lorry to the momentum of the car, then we get 320,000 kilogram metres per second. So that is the total momentum. The momentum of the lorry added to the momentum of the car. The law of conservation, the law of the conservation of momentum tells us that once the lorry smashes into the car, the total momentum will still be 320,000 kilogram metres per second. So, here it is worked out. We've got the truck with 300,000 kilogram metres per second. I think I made a mistake a minute ago. I said 30,000. It's 300. Yeah, sorry. It's 300,000 kilogram metres per second plus the car's momentum of 20,000 kilogram metres per second gives us a total of 320,000 kilogram metres per second. After the collision, now look at this. This is the tricky bit. After the collision, the total mass is bigger. Because after the collision, you've got the lorry and it's smashed into the car, and then they will both be moving forwards. So we have to combine their two masses. And the mass of the lorry was 15,000 kilograms, the mass of the car was 2,000 kilograms. So if we add them together, the mass is 17,000 kilograms. That's just the lorry attached to the car. So you imagine the lorry moving along and the car is sort of embedded in its bonnet. So they're stuck together as one object that is now 17,000 kilograms, the 15,000 plus the 2,000. So we know the mass, and we know the momentum is exactly the same. That's what the law of the conservation of momentum tells us. It would be 320,000 kilogram metres per second. Now what that means is, if we wanted to, we could calculate what the velocity is now. So obviously, the car, I've just been smashed into by the lorry, the car will have sped up a bit, and the lorry will have slowed down a bit, and they'll be steaming forwards, the lorry and the car stuck together, 17,000 kilograms. So the way we do that is we take the momentum, which we know is 320,000 kilogram metres per second, and we divide it by the now larger mass, 17,000 kilograms. And using that calculation, we can work out that whilst the car was doing 10 metres per second, once the lorry smashed into it, it's going to accelerate to 18.82 metres per second. And unsurprisingly, the lorry, which was doing 20 metres per second, after it has smashed into the car, it will slow down just a little bit, as you would expect. So the velocities of the two objects change, but the momentum has stayed the same. And that enables us to figure out more information. Okay, stop.